Okay, everybody, let's talk logs. So the whole reason we need logs is that they make exponents not exponents anymore. So you'll see the definition of a logarithm written as like a double arrowed thing where you have like something like a equals b to the x. So if the purpose of a log is to make an exponent not an exponent, it makes sense that that guy, the x, is by itself. And then we have log and then base of something of another. So the question's where do the a and the b go? Well, the base of the exponent is the base of the log. So that's how you can remember it. And then the a is the only thing left. So that's what we have. And by the way, if I am going to go from log form to exponential form, the way I remember how to do this, if I have something like this, if I raise both sides, if I do b to the on both sides, that sounds really weird, but if I do b to the like this, so b to the log base b, those are they're inverses of each other. They undo each other just like squaring undoes a square root. So that goes to by itself, and we have a equals b to the x. Oh, look, that's the thing we had before. So this is our definition of a logarithm right here, which I know is probably the most useless definition ever made. Whatever. Okay, the things we need are to know the log rules. So our log rules, the product rule, I'm going to use all natural log because in calculus, natural log is the only thing we ever use. In fact, if you ever have something that's not natural log, you have to change it to natural log. That will come up in a second. So like if you have two things multiplied, like natural log of a times b. So one thing that logarithms do is they knock everything down on the order of operations. So like when, thinking PEMDAS, and I always write it this way. So multiply gets knocked down to add. So natural log of a times b is natural log a plus natural log b. Quotient means divide, of course, so natural log of a over b. Well, division gets knocked down to subtraction. So natural log a minus natural log b. Power, so something like natural log of a to the power of b. Well, exponents get knocked down to multiply, so that's b times natural log a. And then finally, the change of base, which is what we need when you have something that's not base e, the natural log. So if you have like log based a of b, you can change that to any base. The only one we're going to care about is natural log, so I'm going to change this to natural log. And the b and the a are going to go in one of those two spots. You can remember it is the base of it. That a is low, it stays low. The b is higher, it stays higher. So here are your four log rules. And the reason we want them is, say you have a function like this, natural log of x sine x. That's a super complicated function. It's better if we have something that is like two simpler functions connected with a plus in between, or a minus, or whatever. So instead of natural log of x sine x, I can use that product rule and write that as natural log x plus natural log sine x. This will become apparent why we need these a little while down the line, but this is the main stuff we need. Okay, so if we had something like this guy, natural log of x squared over cosine x, that is just gross looking, isn't it? So division becomes a subtraction, so I have natural log x squared minus natural log cosine x. By the way, whether or not you have parentheses, it kind of doesn't matter that much. If it helps you to understand what's going on with it, you do it. But looking at that guy, oh wait, we can use a power rule on that. So I have 2 natural log x minus natural log cosine x, because that's as simple as we can make things. Believe it or not, that's simpler. Who knew? Okay, looking at this guy, now there's something we need to watch out for. When you see something like a tangent squared x, your thought bubble really needs to be, oh, hey, that really means, like if I'm the x, I'm getting tangented first. I forgot my x. I get tangented first, and then after that, I get squared. So really what we're saying with that, just to make it maybe a little easier to look at, I don't know how easier looking this will be, but whatever. I'm going to throw that in parentheses. So that squared can move to the front. So I have 2 natural log of tangent x. By the way, if you had something like a tangent x squared, that is squaring the x first. So if you were the x, you're going to get squared and then tangented. And then you couldn't move the 2 down. They're not the same thing. If you're ever wondering, hey, are these things the same? Grab your calculator, throw a number in, and try them out and see if you get the same results. So this is what you really need to be able to do with logarithms, that and your change of base.